Hello. In this video, I'm going to give you an ultimate introduction of Terraform in a very simple English. If you are expecting to know everything about Terraform end to end, then this is not the video for you. But if you are interested in learning the basics of Terraform, understanding the fundamentals of it, then this is the video for you. Let's look at the agenda to see if you are excited or not. First, I'll give you an introduction about Terraform. Then we'll see why, what, and how. Then we'll talk about the Terraform configuration language. Then I'll walk through some of the infra code. Then we'll have Q&A and snacks. No, we are not going to have snacks because this is not a offline session. So bring your own snacks and let's start. Expectation. At the end of the video, this is what I'm promising you. By the time you complete this video, you'll be able to understand what's happening exactly in the Terraform code. You'll be able to read the existing Terraform code, at least 50% of it. You'll be able to play with it, and this will be the starting point to deep dive on your own if you want to explore more. Okay, let's start the video. Thank you. That's it. We'll see. We'll meet next time. Oh, sorry. I think this is a wrong slide. Yeah, Terraform. Terraform is a infrastructure as a code tool, meaning you'll be able to procure your infra from a cloud provider using the code. And it is developed by HashiCorp company, and it uses HashiCorp configuration language as a syntax. And we have free and software as a service versions available. But wait, why we need a Terraform? What is Terraform? Let's ignore the Terraform for a bit now. Let's say you have a business idea, uh, and that idea is about creating the student application. This is basically a web page where colleges or schools can log in and add features like student basic details, attendance, and fees. Okay, so let's try to understand what is the tech behind it. First, talk about the code. We need a web page where admins will be able to log in and perform some actions, and APIs to give you the data and transfer the actions. We can use HTML and JavaScript for the web page, and then we can use basic Python with the Flask framework for the backend APIs. Let's talk about the infra, because we need to host this code somewhere, then only users will be able to use it. We need an instance, VM, or a computer so that we can host our code, and then we need a database to store the user details or student details. And for now, we will stick with AWS as our provider, and we use its AWS EC2 and then RDS missions. We're gonna use the small tier versions. Okay, so now we have created the application, we launched the application, and it was a success. We got some user count. Okay, this is our current setup. We have one AWS account called prod, and then we have a EC2 and then RDS mission here. Now we want to add few features, but we can't directly add the features to the prod because there is a high chance that we might break the system and the users might face a downtime. To avoid that, we need to replicate our environments. So let's replicate them. We will create a 4 environments called dev, QA, staging, and we create the same setup in each of these environments by manually logging into them. Yeah, one task is done now. And again our application become successful again, and it got a wider reach, and we had more users now. And now the load is more and system is not able to handle that. So we have to upgrade our system. This is our current setup. We have one EC2 and RDS small tier version. So let's increase the EC to a bigger version. Okay, so now what we need to do, we need to log into each of these AWS accounts and then manually upgrade them. Okay, done. Let's say we have added more features. Let's say we have 45, we have started using 45 services of AWS now, and we also deployed this solution in multiple regions, meaning the same application can be deployed in multiple regions. One can be in India, one can be in UK and Singapore. So imagine making changes in all these environments and regions manually. That's quite a task. We need to have a solution. What is the solution? Terraform. With Terraform, what we're gonna do is we're gonna create a single configuration file repo. From that repo, we can push the changes to all these environments. Quite simple, right? Why we need Terraform? It's an infrastructure as a code tool, meaning we can maintain our infra in the form of a code. Incremental changes, it is best suited for the incremental changes. Say you already have some existing setup, now you want to upgrade something or add something, then this is the best tool for you. Multi-cloud, meaning the same syntax can be used for the different clouds. We have cloud providers like AWS, Google and Azure. For all of these we can use single Terraform syntax. Easy deployments, with Terraform your deployments will become easy, meaning you can use the same setup to deploy in multiple environments and multiple cloud. How exactly it works in how exactly the Terraform works in the background? We'll try to have a look how it works. Suppose you wanted to create 5 resources in a cloud environment. What we will do, we create 5 resources in Terraform by writing some code that we will see in the further slides, and then we simply push the changes to cloud. That's all, simple. Now say we wanted to add 7 resources, but we already have a 5 resources in our cloud. So we just need to add the two new resources extra. We should not create all the 7 resources again. How we gonna do that is using a feature called state file. This state file is nothing but having a reference of what exactly already there in your cloud. uh, when we try to push the changes, right, it will go to the cloud and it will refreshes and it will create a state file with mapping of the existing resources. So with this we will get to know that 5 resources already there, and it will automatically just add the 2 new resources to the cloud. Okay, and this is how the sample flow of Terraform. First we will be writing our code, and then we will be running the plan means it will just give you what are the changes that gonna happen, but it won't actually do the change, and we can simply use the apply command, and then through the providers we will be able to do our changes. How we communicate to the actual cloud providers? Suppose this is our cloud environment and we have cloud providers like AWS, Google and Azure, and say this is our Terraform config files, and we have a feature called providers. These providers are nothing but the custom plugins that each of these cloud providers have built. Our code will directly talk to these provider plugins, and these plugins will talk to the cloud. Okay, features. So if Terraform is a tree, then it has several features. We'll talk about all of them one by one. Providers. It's an important feature, yes, and it is the medium to talk with the cloud. Suppose you are working in a company and you have a company owner. You can't directly talk with your owner, right? You should have a manager. So whatever you need, for suppose if you want to leave or if you want to have a salary hike, that you need to discuss with your manager, and manager will directly talk to the owner. And say you want to receive some information about to whom you are selling products, to whom your business is serving to, so the owner will give you those information like product scope and client info, will give you the information to your manager, and then your manager, from your manager you can get the information. So you can assume the provider as a mediator between you and the actual cloud. Okay, these providers are usually declared in the root module. Let's see the example. So this is how you can create a provider. Here you can see we have created 2 providers. 2 of them are mapping to AWS, but both of them are mapping to different regions. Whenever we use a different region, we need to use a different alias. so that we can uniquely identify them. Resources. Again, it's an important feature. Resources are nothing but an infrastructure object. For example, if you have an EC2 machine or a database or a VPC, all of them becomes an resource for you in the Terraform language. It is declared in the root module. Example, here you can see we are creating one instance. The resource is the reserved keyword, and AWS instance is the identifier for which resource we are creating, and web is the custom name that we have defined, and remaining are arguments. And we have some meta arguments which can be used for all of the resources. With this, we will be able to perform some extra operations. For example, let's say we want to create a multiple EC2 instances. Then we can rely on the meta arguments like count and for each. Data sources. This is the information exists outside your Terraform code. For example, through your Terraform, you have created 5 resources. But in your environment, there are some 10 resources. But you don't want to create those extra 5 resources, but just want to have a reference to them. That's when we can use the data source. Example. So here you can see we want to have a reference for the existing AMI. So we simply create a data variable, data block, and then we reference them. This is another example again with the data variable, data keyword. We are referencing a AWS SSM parameter so that you can use that in the remaining code. Variables. Variables are nothing but variables in a general programming language in Terraform. We can use it to make our operations easier. We have different types of variables. One is input variable. If you know about a general any general programming, right? Input variables are nothing but, for now you can assume, the variables that are parameters within a function. And local variable is the variable that is created within the function. And output variable, the variable which will be returned from the function. Okay, let's see the example. This is how we're going to create a variable. First we will define a block with a keyword called variable, and then we will define our own name, and we can use the type to specify the which type of variable we can create. Terraform supports list, string, integer, and map variable types. And this is how we will create a local variables. With locals block we can create variables and then use within our module. Reuse the, if you ever wanted to reuse, then we can create this local variables. Output variable, this will be created using a block with output, and these values can be used by the other functions or modules. Files and directories. We have files that will be identified using extension called .tf or .tf.json. JSON will be used for the JSON structure. And here you can see some of the sample plain files: main.tf, output.tf, and variables.tf. Directory is nothing but a group of Terraform files in a folder. Module, we'll talk more about the module in the next slide. A module is a container of multiple resources that are used together. It's an important feature again. And we have child module concept, root module concept. Here you can see Cognito and ECS are the modules. And this module can be treated as a child module by calling it from the root module. So here you can see on the right side, we created a module block, and then within the source we are referencing the Cognito child module. Module output, basically your module can return some values, just like we talked about in the previous slides. Just like a normal function can return a value, your module also can return few values so that it can be used by the other modules. Here you can see instances equal to module.servers.instance IDs. So this instance underscore IDs is the output variable from a module. Root module, every Terraform will have a root module. So whatever the Terraform files exist in this root module will be executed first. You can just treat module as a function. So basically you can assume it like you have a main file. From within a main file you can call your child functions. Backend. how your cloud state can be maintained, that can be defined using backend. So that can be stored locally or it can be stored in the remote. So we use this feature called state information to have a reference of your existing cloud setup, and this can be implemented using one of these features in the right side: local, remote, s3. And workspace is, let's say you have a cloud setup and within that you wanted to maintain two projects, so you can segregate between them using the workspace concept. You can create multiple workspaces for different projects. Remote state, this will be used when you want to enable a state locking feature. For example, if you have a multiple people working on your project, you don't want two-person to update the cloud at the same time, because it might leave your infra in a ambiguity state. That's when we can use the remote state. Variables, we have already talked about the variables in the previous slides, but here I'm gonna talk about the some extra feature available within the variables. These variables files can be declared at the module level, and then the variable files with the extension .tf are automatically loaded. Here you can see we have a folder called tf. So here we can directly define few values, but these are not automatically loaded because these are in a child module. So here we can see I have defined few variables and then these values, and this is the variables.tf file. So just like a programming language like C, where we need to define the variables before using it, we have to do the same way here. We have to define the variables first and then we can assign the values. And here we can see we have a file with extension .tf. So these values are automatically loaded. So when you have some default values, that can be defined here. And while running the plan or apply command, we can pass the extra variable files. Here you can see we are passing some variable file using the -var and -file type. With this, if you wanted to run your code with the different environments, then you can pass the different files. Code, actually I wanted to show the infra code, but because of some business constraint I can't show you the my existing code. But we have seen some examples in our previous slides. You can assume that as some sample codes. Further readings, if you want to know more about Terraform, you can start reading these concepts as well. Expressions and functions, when you wanted to create a variable with a different relying on different conditions, then you can rely on these expressions. State lock, basically when you don't want to leave your infra in an ambiguity state, then you can use the state lock feature. State import, when you have few existing infra already created in your cloud, but you want to start using them in your code, then you can use this state import feature. Yeah, that's all. We can have a Q&A now. So whatever the questions you have, you can add it in the comments. And if people already know the answers, they will reply, or I'll try to see and reply. Okay, that's all. Thank you. If you like the video, maybe leave a comment, give it a like, so that it will reach the more appropriate audience who are in need for this. Thank you. Wait, I have written a small poem for you guys. Thank you for giving me 20 minutes from your clock. Manual maintenance of infra is quite a shock. So after this TikTok, hope Terraform is a cakewalk. Thank you. We'll see you.